Hi, welcome to this video where today we're going to be talking about how to simplify rational expressions as well as how to state the excluded values of an expression. I talked about excluded values in my previous video where I showed you rational functions, the equation of a rational, but today we're just going to look at the expressions. We're going to state the excluded values and also simplify them like I mentioned before. So those two skills are here. Feel free to follow along with me the best you possibly can. All right, so here, first we have three problems. And again, it says state the excluded values. In my previous video, I told you that excluded values are the values of the variable in the denominator that it can't be. Because if it was that value, the denominator would be 0, and we know we're not allowed to divide by 0. So again, the excluded value solely is about the denominator, not the numerator. And it's what the value can't be, because if it was that value, the denominator would be 0, and that's impossible. So for this first one, 3b plus 2 over b plus 7. If I want to find the excluded value, I'm solely setting the denominator equal to 0. And if I set b plus 7 equal to 0, my excluded value is -7. So that means b could be any number in the world except for -7, because if it was -7, the denominator would be 0. Next one, 8 over 2x plus 1, I set the denominator equal to 0. If I subtract 1, then divide by 2, I get -1/2, and so -1/2 is my excluded value. Last one here, a squared minus a minus 12. So this is not just a friendly little binomial, it is a trinomial. We should remember that when we set a trinomial equal to 0, we then need to factor it. The factor pairs of -12 that add up to give me a -1 are -4 and -3. So imagine I did, I set this equal to 0 and then I solved. So again, remember, factor pairs of 12 that are going to somehow give me a -1 would be a 3 and a 4, a -4, and it should be a +3. So then if I have a minus 4, that means my first excluded value is +4. And if I have a plus 3, that would mean my second excluded value is -3. Okay, and those are my two values for my excluded values, 4 and -3. Now, next few problems, it says simplify the expression and state the excluded values. Now, when we go to state the excluded values as our second step, it says in parentheses here, we always have to go from the original expression. So we don't do the excluded values from the simplified expression. We always have to go back to what it originally was. Now, there's a lot of situations here that are going to happen when we go to simplify these expressions, and they all go back to factoring. So let me just give you a really quick remembering, review on factoring. First of all, if you have a binomial, a two-term polynomial, there's only two things you can do. Factor out a GCF, a greatest common factor, or factor it if it's a difference of squares. So a perfect square minus a perfect square. And we're going to have those cases here. This 4x plus 16, this x squared plus 25, this 8x minus 40. It's either going to be factor out a GCF or factor it in that fancy, difference of squares format. If it's a trinomial, then we have to do what we did before. If the trinomial starts with an a value of 1, which the three trinomials here, the denominator of problem 1, the numerator and denominator of problem 3, they all have a values of 1, then it's simply what factor pairs of c add up to give you b. So here in this first one, 4x plus 16, it's a binomial. It's not a difference of squares. There is a GCF of 4. So I'm going to go ahead and factor out a 4 of my GCF, and then in the parentheses, I would have x plus 4. My denominator is the trinomial. What factor pair of -36 is going to add up to give you -5? 1 and 36? No. 2 and 18? No. 3 and 12? No. 4 and 9? Yes. It would have to be a +4 and a -9. And remember, it doesn't matter what order you write them in factored form, but the signs matter. So the negative has to go with that 9. The 4 has to go with the plus sign. Because again, when you add these up, you get -5. And when you multiply them, you get that -36. Now, the reason why factoring out is so fun here, it's friendly in this case, and it's kind of satisfying too, is that we're trying to simplify this expression. And notice that x plus 4 and x plus 4 in the numerator and denominator. We get to cross both of those out And then our simplified expression is just 4 over x minus 9. That's it. That is my final answer. I can't go any further. I can't do 4 divided by x or 4 divided by a negative 9, so it would simply stay. Now, the excluded value part, notice it says are always from the original. So I don't do my excluded value from 4 over x minus 9 because that would only give me one little excluded value. I technically have to do it from the original. This is the original denominator, x squared minus 5x minus 36. And we already know in factored form, it was x minus 9x plus 4. So that really means if I took that denominator and I set it equal to 0, and I already know what it looks like in factored form, x minus 9, x plus 4, that's going to help me get to my excluded values of a positive 9 and a negative 4. If I had looked at it from this here, the simplified, I would have only gotten that 9, and I would have missed half of my answer, which is negative 4. So again, you always go back to the original. Lucky for us, we already factored it, and then we can use that factored form to solve. Okay, next one, x squared minus 25 over 8x minus 4. You can see my dog in the back. Okay, so x squared minus 25 is a binomial. It's not like 4x plus 16 where there was a GCF. Instead, it's a difference of squares. So it's a perfect square minus a perfect square, x squared minus 25. And hopefully you remember how to factor this. It's the square root of the first term, square root of the last term. So square root of x squared is x, square root of 25 is 5. One gets a plus, one gets a minus. It's been a while since we've seen that, but that's what you would do. Now the denominator is also a binomial, two terms. It's not a perfect square minus a perfect square. It's kind of more like this 4x plus 16. So I look for my GCF. My GCF of 8x minus 40 would be 8. And if I factor out an 8, I'm left with x minus 5. Now, I think you can probably already see what's about to happen. We want to simplify this, and the way we simplify is we cross out the expressions that we see in common in the numerator and the denominator. Whatever I'm left with is my simplified answer, x plus 5 over 8. Now, the excluded values. Remember, we don't go from this answer. We go from the original. So my excluded values would be to do 8x minus 40 equal to 0. Solve, so I would add 40, or I could factor out an 8 here, which is what I did. You could add 40 and divide by 8, or simply factor and then set x minus 5 equal to 0, and we would get 5 as our solution. Again, you would get the same thing if you took this equation and you added 40 and divided by 8. So my excluded value is 5. Last one here like this. So my trinomial here. This is where we have to figure out what numbers multiply to get negative 35 that add up to get negative 2. 1 and 35? No. 5 and 2? No, I'm sorry. 5 and 7? My apologies. Yeah, a 5 and a 7. So a 5 and a 7 will multiply to get negative 35, but which one needs to be negative so that when you add them, you get a negative 2? Should be the 7. So x minus 7, x plus 5. Now my denominator, what factor pairs of 14 add up to negative 9? 1 and 14, no. 2 times 7, yes. What kind of 2 and 7 do you need to get a negative 9 when you add them? Both negative. You should be able to easily see what's happening here. X minus 7 over x minus 7 is gone, and my simplified answer is x plus 5 over x minus 2. Now, do not cross these x's out. You can't. You can't. The only reason why we're able to simplify out what we can is because that value that we're crossing out is being multiplied by another value. You can simplify things out from multiplication. You can't simplify things out when they're being added or subtracted in the numerator or denominator. Excluded value, we set the original denominator equal to 0. Good news for us, we already have it in factored form, x minus 2, x minus 7. So that means my excluded values are 2 and 7. So this is a really good combination of skills here. Simplifying a rational expression using our factoring and then crossing out what we see in common, and also the excluded values. Okay, some more problems that have some other different skills in them. So here we have 6xyz cubed over 3x squared y squared z, a monomial over a monomial. And we actually did this mid-year where we were simplifying expressions like this, and it's just a lot of cross simplifying. So remember, we would cross out the 6 and the 3, and that would become a 2 over 1. X over x squared, you can cross out the x and turn the x squared into just x to the first. Y over y squared, cross out the y, make this just y. And then z cubed over z, cross out a z on the bottom, z cubed at the top becomes z to the second. So I'm left with 2z squared. I always have to look really carefully to see what's left over. And in my denominator, it's just xy. So now the excluded values. What's interesting about this is anytime you have a monomial, this only works when you have a monomial, all of the excluded values, the x, y, and z, because remember it's got to come before you simplified it, will always be 0. Because the moment one of those is 0 and then it gets multiplied by everything else in that denominator, it's going to become 0. So whenever it's a monomial in the denominator, you'll see the next one is just like that. All the excluded values are 0. All right, so let's simplify what we can here. So 36 over 20, greatest common factor is 4. So that becomes 9 over 5. K to the third over k squared, cross out k squared, this becomes just k. N over n, those are both gone completely. And then if I cross out p squared at the bottom, I get p to the third. So my numerator I'm left with is 9k. My denominator is 5p cubed. So that's my simplified expression. And also note with this one too, you know it's simplified because there's nothing more you can do with the numbers. And notice you don't see the variables repeated. If you saw the same variable in the numerator and the denominator, you could keep going. And of course, my excluded values here, like I mentioned before, if it's a monomial in the denominator and they're all being multiplied by each other, all the variables, then they're all going to be 0, which is super, super easy. Okay, a couple more problems like we did on the beginning of the notes, which is good. X squared minus 81. So that's a binomial. Is there a GCF? No. Is it a difference of squares? Yes. X squared minus 81. So square root of the first term is x. Square root of the last term is 9. One gets a plus, one gets a minus. Doesn't matter the order. Denominator is a trinomial. What factor pair of 27 adds up to get negative 12? 1 times 27? No. 3 times 9? Yes. What kind of 3 and 9 do you need? Both negative. You need them to both be negative, so they add up to get negative 12. And if they're both negative, they'll multiply to get that 27. So then I get to cross out x minus 9, and I'm left with x plus 9 over x minus 3. And please remember, you cannot go any further. You cannot cross those x's out. The only reason why we were able to simplify that is because they were expressions that were being multiplied by another expression. Here, x is not being multiplied by anything. 9 is not. You can't do 9 divided by negative 3. Trust me, this is it. Excluded values, remember, always come from the denominator. So if I was to take that denominator and set it equal to 0, we already know that this would be the denominator, set equal to 0 in factored form. If I've got x minus 9, my first excluded value is positive 9. If it's x minus 3, my second excluded value is positive 3. Okay, r squared plus r minus 6. So factor pairs of 6 that are going to give me a 1. 1 and 6, no. 2 and 3, yes. They need to add up to get a positive 1, because remember, that's really the coefficient here in front of that r. So it's got to be a positive 3 and a negative 2, because those will add up to give me positive 1, and they'll multiply to give me that negative 6. Denominator, okay, so 12. We need a 4. So 1 times 12, no. 2 times 6, yes. What kind of 2 and 6 do you need? So you get a positive 4 when you add them up. It should be a negative 2 and a positive 6. You can nicely see what's going to happen here. My r minus 2's are gone. I'm left with r plus 3 over r plus 6. My excluded values always come from the original denominator, set equal to 0. So it's already in factored form. If I have r minus 2, then my excluded value is 2. R plus 6, my other excluded value would be negative 6. Awesome. Now, these problems here are a little bit more complicated. You can see a little bit more of the work because these are the types of trinomials where you needed to do definitely some more work. So first of all, I see that they all have a values that are not 1. Number 5 is going to be kind of friendly for us because what we should see is that there is a GCF here in this numerator, and it's 2. So if I factor out a 2 from each one of these terms, I'm left with x squared plus 9x plus 18. Look in the denominator. I can factor a 3 out of each one of those terms. So this is I'm left with x squared minus x minus 12. Now remember, anytime we've ever factored a number out, it just hangs out there. We're not going to distribute it back in. We really are just worried about what's in the parentheses. So what factor pair of 18 gives me 9? It would be 3 and 6. What factor pair of negative 12 will give me a negative 1? It should be a negative 4 and a positive 3. My x plus 3's are gone. I'm left with 2 times x plus 6 over 3 times x minus 4, and there's honestly no need to distribute. You can leave it in that form. Excluded values, remember, always come from the original denominator set equal to 0, which we had started to factor with the GCF, which then was in factored form here. So if it's x plus 3, my first excluded value is negative 3. If it's x minus 4, the other excluded value is positive 4. Now, this last problem here, these are trinomials where it's not as friendly with the steps because there is no GCF, but we do need to remember how we are supposed to factor these trinomials. So what I'm going to do, I'm just going to create a big workbox right now so I can do my work here. Okay, so 2y squared plus 9y plus 4. Remember, this is the type of trinomial where when the a value is not 1, you have to do 2 times 4 is 8, and then figure out what factor pairs of 8 add up to 9. It should be pretty easy. It's just 1 and 8. What kind of 1 and 8 do you need to get a 9? They would have to both be positive. So this is where you do 2y squared. You break apart 9y using the 1 and the 8. So plus 1y plus 8y. And then we bring down that plus 4. It's been a while since we looked at problems like this, so that's why I'm doing this review with you. Then we have to mentally or physically kind of split this in half and do our factor by grouping. So the GCF in this first binomial is y. So then I'm left with 2y plus 1. The GCF in the second set is positive 4, so plus 4, and then 2y plus 1. And we know we're in good shape because we see the twins. Okay, what's in the parentheses should be identical. And so this in factored form is y plus 4. Okay, it's the GCFs. And then one of the twins, 2y plus 1. So that there is the numerator. I have it in a different order, but it doesn't matter. Okay, so now the second problem. The denominator, 4y squared minus 4y minus 3. So 4 times negative 3 is negative 12. What factor pairs of negative 12 are going to give me negative 4? It should be a positive 2 and a negative 6. So 4y squared plus 2y minus 6y minus 3. I go ahead, I factor out my GCF of my first two terms. It's 2y. Then I'm left with y plus 1. Ooh, 2y plus 1. My apologies. Now the second second binomial, I need to factor out a negative 3. And that's going to leave me with 2y plus 1. So my factored form would be my GCFs of 2y minus 3. And then one of my binomials, my twins, 2y plus 1. This then, after that works out nicely because those get simplified out. My final expression is then y plus 4 over 2y minus 3. My excluded values come from the original denominator set equal to 0, which we have in this nice factored form. So if it's 2y minus 3 equals 0, think to solve for y, you would add 3, divide by 2. So that first solution would be 3 over 2, or 1.5. If I have 2y plus 1 equals 0, I would subtract 1, divide by 2. So I would get -1/2 or -0.5. And those would be my excluded values. I know there's a lot going on in this video, a lot of factoring review. If you're really struggling with any factoring review, you're really not sure about the difference of squares or factoring trinomials, please make sure you go take a look at my other videos, just as a quick refresher, and then you should be good to go. Thank you so much for watching.